Today what we are going to start talking about is the beginning of Chapter 4. Now, first thing that I want you to recognize is that you need to read on your own Chapter 4. We are not going to do all of Chapter 4, however. We are not going to do anything about rotational motion, so you don't have to worry about that part right there. So the last section, you don't have to worry about of that chapter. But anyway, read through it, make sure that you're good with it. The vast majority of this should be a review. All we're going to start talking about here are position vectors, which shouldn't be too much of a drastic change from what we've done last year. The biggest thing that is going to be different from what we did last year, we did our XY charts, we did our velocities initial, velocities final, yada yada. We did it in the X, we did it in the Y. But what we're going to do now is instead, when we have a position vector, let's call it R vector equals some value I hat plus some value J hat plus some value K hat. So instead of just having X and Y, now we have X, Y, and Z. It's just going to be in a slightly different notation. So no real changes on that portion there. All right. Now, the big change is going to be when we get into velocity vectors. Now, when we talk about velocity vectors, last year we talked about average velocity, which is basically how much your velocity is changing over a period of time. That's when we used the VF minus VI over T, or I'm sorry, I apologize, not VF, this would have been final position minus initial position over T. This is average velocity. Average velocity is taken over a significant period of time. Right? What we are going to be talking about now is instantaneous velocity. Now, the difference between instantaneous velocity and average velocity is, obviously, average goes over a long period of time, instantaneous is over a very short period of time. In this case, instead of talking about time as a discrete number, we're talking about an infinitesimally small piece. Okay? So basically, instead of having basically delta x over delta t, which means you have a position changing over some period of time, this would be your average velocity. Now what we have is dx over dt. Now, dx over dt is a derivative. Now, the neat thing is, if you know the basic equation for what x was, what the position vector was, you can figure out what the instantaneous velocity is at any given moment just by solving with the derivative. Okay? If you have already gone through calculus, pre-calc, anything like that, and you already know about derivatives, you can skip the next video lecture. The next video lecture is just going to involve what derivatives are and how to do some basic ones of them. Okay? But either way, this is the instantaneous velocity. Now, and the same thing that we did before. We had acceleration, which was also an average value. We're changing that over to an instantaneous value now. Right? The value in this is that now, instead of just knowing over the extended period of time how much is it accelerating, we now can do at any given second or split second. You can narrow it down to that small of a fraction as long as you know what the value is for it. Okay? Acceleration, the average acceleration was a change in velocity over a change in time. All right, I'm going to put a hat on these as well. Instantaneous velocity is going to go dv over dt. Now basically, this means the same as this, but the delta value is much, much smaller. This is over an extended period. This is over an insanely minute period. Okay? Now, the other thing that's neat about this, the instantaneous acceleration, this should have a hat as well, is also, if you were to take the second derivative of x with respect to t. Okay? So we get some neat little tools, some neat little toys that work together here for us. Okay? Now, what I'm going to do, I'm going to wrap up this one with the basics of the basics here. Just kind of show you how this works out. If you don't know how to do this, if you don't know anything about derivatives, then please watch the next video lecture. The next video lecture is going to go into how to do the basics of it. This is not going to be something where it's an in-depth analysis of everything. This is just going to be the basics of the basics. I'm expecting you'll learn more in calculus about how to do more derivatives than this. Okay? But in general, the key thing to remember off of this, let's say that x is our position vector. If we were to take the first derivative of x with respect to time, that's going to give us our velocity, which is also a vector, and d squared over x. Pardon my faux pas writing there. D squared x over dt squared is going to be acceleration, which is also dv dt. And all that is going to also be equal to the vector A. Okay, so all this is telling you is the same stuff that we'd learned before. If you take a change in position over time, you get velocity. You get a change in velocity over time, you get acceleration. This is just using more advanced mathematics than we had available last year. Should not be too critical, and I'm not expecting you to have too many troubles with it. All right? Otherwise, if you have any questions, please let me know. I will get that rolling as quickly as I can. But that is about it. Move on to the next video lesson if you need help with derivatives. If you do not need help with derivatives, fast forward to the very end of the next video lecture, and it will have some practice problems for you. Okay? Good luck.